Sorry about that. So yeah, so very interesting domain that is up and coming is what is called as neuromorphic computing, where you might have all heard about deep learning, but deep learning is completely based on software models. You might have heard of Python. Python is the go-to programming language for building deep learning models. But the next level of optimization, it's like your calculator. You all have used a calculator, and if you look at just the calculation time, your calculator is going to be much faster than your computer, because computer goes through many transformations of your program. Say you write a C program for multiplication, the C program has to be compiled, it has to be converted into intermediate code. Intermediate code is compiled into machine language. Machine language is fed to the processor, and it goes through many iterations before you get the answer. But if you look at the calculator, it's hard coded. Directly, there is no operating system, there's no programming language, there's nothing. And directly you uh, have the answer or have the calculation in terms of digital units who are doing the calculation, and that's the extra level of optimization that you will get with creating a specific, or what is called as application specific integrated circuit. And you can either do that, or you can build something a little simpler using a FPGA, and that's what neuromorphic computing is focusing on. uh, and of course, there's always the question, what are we doing beyond CMOS? Because if you will see some of the circuits that they are building today, they are reaching a point where CMOS, for example, we already said that semiconductors depend completely on silicon. And silicon, of course, is a atom. An atom has a size. uh, what happens when your transistor starts nearing the size of the atom? You can't make a transistor smaller than the silicon atom, but we have reached that limit here, and everybody is very curious to see what will happen. How will this community, or how will this technology go beyond that particular bottleneck? And this has been a question for a long time. Even when I was a student, beyond CMOS was a question, but people have found ways to try to not eliminate silicon, because it's such a big advantage to have something as simple as silicon and such reliability. And we know so much about silicon. People are keen on moving away from silicon. So they've innovated and found ways to stick with silicon and still keep driving the industry at the rate predicted by Moore's. And of course, one important thing to mention here, the most modern type of integrated circuit is what you call as system on a chip. And almost all of us have one. If you have a mobile phone, a smartphone, you have a system on a chip, because your mobile phone has everything. It has communication circuitry. If you have a phone that can sense whether it's being held upside down or not, that means that it also has some MEMS circuitry. MEMS is also called micro electromechanical systems. These are a combination, these are mechanical systems, but they are in the micrometer range. And they have digital circuits, of course, for the computation part, and they have analog circuits in between, because the signal that is coming from your cell phone tower is an analog signal, and it has to be converted into a digital signal, because the computation can be done only in the digital domain. And you have the signals going out, which means that your digital signal has to be converted back into analog, etc., etc. So all of this, if you can imagine it or not, is inside your phone. And more importantly, it's in a single integrated circuit. This integrated circuit is one of the most complex systems in the world. It's called system on a chip, because there's many types of different types of uh, functionalities, different systems that are all on the same integrated circuit. So one of the most modern innovations of this integrated circuit is your SoC, or system on chip. So finally, we come to this important question, that is, what is integrated? right? I mean, we know what is the meaning of the English word integrated. Integrate means our nation is integrated, means we are all united. But what is the meaning of integrated circuit? And the keyword, of course, is integrated. And what that means is we are building everything. So we saw an example of SoC or system on chip. The problem with having all of them separate, that is, if you're looking at a traditional discrete circuit, they're all separate means it takes a lot of time for the signals to pass from one block to another, and that reduces the speed. Instead, if you're able to make everything on the same substrate, so we don't know what is substrate yet, but you imagine it's a semiconductor, it's silicon. But you imagine your breadboard, right? The white color breadboard. Now you imagine a silicon semiconductor like that breadboard, okay, but only about 1 lakh times smaller. That is your substrate, and all the elements of your circuit are on that substrate itself. There's nothing outside of that. All the computation happens inside. Everything is very fast. Okay, that is the most important property of integrated circuit. The second property that you see here is, of course, it's dense. It's very, very compact uh, compared to a munch. Suppose you had a pocket calculator that was the size of your monitor. It would be so much more inconvenient. But your calculator today is so compact, and that's because it has calculator, of course, has a few of these, but each of them is a very compact circuit in itself. So you're able to fabricate all of them on a very, very simple PCB, and that is one of the importance of integration, having all of them on the same on the same substrate. And the third most important thing is when everything sits on the same substrate, lifetime of that product is higher. You don't want to be changing your mobile phone every 3 to 6 months because something stops working, right? And the reason why this doesn't happen is that whenever everything is inside the integrated circuit, the chances of failure are very low because there are no moving parts. That is one of the most problematic issue with mechanical devices, is that a lot of things are moving, and whenever they are moving they tend to break, and whenever they break at the micrometer range it's impossible to fix. How do you completely eliminate that? You just remove the moving part, have all the functionality inside the chip, okay, and they also fail, and maybe later on we will see some of the reasons why they fail, but they take much longer, 5 years, 6 years, and it depends on the usage. If your usage is very low, then you can extend lifetime exponentially. So that's one of the most important reasons why everybody wants to adopt, everybody wants to shift their functionality to integrated circuits. Uh, the 3 points that you see here, and our particular this thing is called CMOS, and we will talk more about this later. But it's called CMOS VLSI design. This course itself is called CMOS VLSI design because the name of the technology which you see here is complementary metal oxide semiconductor. Is there CMOS, and it's the name of a fabrication process or a technology. So we'll look more into that later on. But the complementary, because there are two types of transistors, NMOS and PMOS, and they are both made on the same substrate. So that is why it is called as CMOS technology. If you remember briefly, we mentioned the first integrated circuit. That particular circuit did not have any PMOS transistors because at that time, early 1970s, they did not know how to make both NMOS and PMOS on the same substrate. So they had to make an integrated circuit with only NMOS transistors. So the more modern version of that is what we have today, so CMOS technology. And of course, everybody is interested in core area jobs. This was not the case in 2000. There were not so many companies that are in this domain. In 2000, hardly there were be two or three companies. TI Texas Instruments, which I have listed here, was there in 2000. And then Bharat Electronics Limited was there in 2000. Government of India Public Sector Organization. Um, but there were very, very, very few other companies which were doing anything in the VLSI domain. Today, of course, there are many more companies. They're all based in either Bangalore or they're based in Hyderabad or they're based in Delhi, Gurgaon. So some of the companies, many of them you've heard of. I'm sure Intel and AMD are of course the largest microprocessor manufacturers. Qualcomm, I just mentioned Qualcomm briefly, but Qualcomm is one of the most important chip manufacturers for mobile phones. They also own a patent, which is one of their most important sources of revenue. Texas Instruments today they're largely a analog uh, thing company. They have a very good presence in Bangalore. MediaTek is a more recent company. It's Taiwanese company and it's a competitor to Qualcomm. So the low-end mobile phones, they all have MediaTek chips because they don't want to spend so much on that part of the phone. They all have MediaTek chips, and MediaTek is a much bigger company only because the volume of those is also very high. Analog Devices is a company that specializes in uh, RF circuits, that is radio frequency communication. We had a person who used to come to our department who worked in analog devices, and he was an RF IC specialist, radio frequency integrated circuit specialist, which means he was making some ICs that had communication capabilities, and he was working on projects in the healthcare domain. So you have a large instrument, some instrument, right, which is doing some sort of measurement. And instead of having all these complicated wires and going here and there, based on very simple communication technologies, you can send the data wirelessly to a nearby computer. It will not send it 10 kilometers away, but to a nearby computer it can send. So he was working on something like that. He was employed by Analog Devices at that time. IBM, of course, you've all heard of, one of the oldest companies in this domain. And IBM, like I said, it's a giant, and even uh, someone as big as IBM in this domain have sold off their fabrication facility. You might have heard of Lenovo, a Chinese company. Lenovo is the fabrication wing of IBM. So today, IBM is what we call as a fabless semiconductor company. So it doesn't have its own fabrication facilities. It does all the design, and it depends on some other third party company in Taiwan or China to make its integrated circuit. So fabrication is a very uh, cost not cost effective, but it's a very expensive affair to set up a fabrication. This thing it costs in the range of 1 lakh crores to set up something like that, and that's why even with all the things happening in India, that's one thing that is still lacking. SanDisk, for example, SanDisk in Bangalore, they are responsible for the 1 TB pen drive. The 1 TB memory chip, solid state memory chip, was made in SanDisk Bangalore. So we have a huge advantage in the design area, but we don't have much fabrication. And it's not necessarily a disadvantage, it's just a fact. And of course, bottom right left corner, two very important VLSI CAD companies, Synopsys and Cadence. Cadence is what we'll be using also for our labs that we will do that is related to this course. And Samsung we have especially mentioned because we have a lot of interaction with Samsung, but we don't have interaction with their real. They have two divisions. They have SSIB, which is Samsung Semiconductors India Bangalore, and they have SRIB, which is Samsung Research International Bangalore. So we are more interacting with SRIB. You can talk to some of your seniors. What sort of interactions? So we'll stop here for a break and then we'll join back in 2 minutes. Okay, thank you.